Okay, so let's talk about the caching. Whenever we are designing any systems and each customer have a one of the basic requirement is that whatever the application we are building, that should be a response as fast as possible. Okay, that means your applications, whenever users send any request, a reply get as early as possible. That is the maybe real-time response at good. Okay, so for that there are lots of technique uh, we are going to still last couple of sessions we are talking how we can reduce the delay, or you can say response times or turnaround times. So one of the techniques to improve the system performance is the caching. Okay, so caching is the one way where we as a software engineer can think, play a system performance improvement tool, you can say. So this is the one techniques. Okay, so let's talk what is the caching, what's up other techniques available, so that whatever the we are building API, we are building applications, we are building system, and that's response as quick as possible. Okay, so let's talk about the caching. What is the caching and what are the different way we can use this caching to improve my application performance. So caching is the again a technique used to improve the performance of a system by. So this technique say how we can improve your system performance by temporarily storing frequently access data in the fast and more accessible to the location. What do you mean that? So here is let's see. I request, hey, as a customer, I say, hey, I need my profile. Okay, so my application received this request, my server received this request. Okay, great, receive this request, and they are going to the call database. From database, they fetch my informations and again come here and prepare the response, and the response get back to the customer. Again, I ask, hey, give my profile. Again, a request go to application server. Application server call to the database, and from database we get data and response. So generally, notice if my profile, if I ask today, and after 5 minutes again I ask, hey, system, can you give me my profile again? So generally my profile is not changed. So which data that frequently not change and users are requesting multiple times, same data are request or user access from the multiple time. So those scenario, why not we go call database and get data? Why not store those calculated data, fetch data locally and response quickly? So objective is that what the data customers frequently ask, we can store locally nearest to the customer locations, and so that our application responds quickly. So this is, you can say, caching is the temporarily storage of the data, the requirement which customer frequently asking. Here one customer, maybe multiple customer. This is not talk about the only one customer. Okay, so let's see it. uh, we have a one application. Let's key my the one particular image we uploaded it. So these images are asked by whenever any users are load his application, this image are load to the every user. So for every user, I am going to the take this image from my file system from a database and restore and send. Instead of that, let's store locally and serve every request. So caching is a help to not the specific customer for across the customer. Might be some data are required to the multiple user, multiple customer. So those stored, temporarily stored nearest to the customers as possible. So in this way, we can make our API, our application response quickly. So this is the basics of caching. Caching means whatever the informations our customers, our application ask from my application server not going to the call particular database or particular file system to retrieve for each and every time. Instead, they first times they get it and store locally and again reply back, right? So this caching allows system to quickly retrieve the data instead of having access the original source, which is slower and more resource intensive. So that means here the simple meaning that now our applications are first times going data get from the original source. Original source may be database, maybe file system, maybe microservice call, maybe third party application call, and store locally. And next request for the same data for the same id come already our application server have locally, they respond quickly. Okay, so let's basic concept whenever we talk about this caching. So one terms is a cache hit, one terms is a cache miss. So let's understand what the meaning of cache hit and cache miss. So let's one request come, okay, and this is my cache server, cache application. So might be the particular data which user requested are not found in the cache. So in this way, cache miss means what the user requested data, that data is not available my cache. So what application do? Application go call the specific database. Hey, this data user request, retrieve this and store here and response them. So this is the cache miss. Cache hit means now next time user requests come, hey, need this data. This data already available in the cache server. They quickly respond. They are not going to call again the database. Cache hit means ki already requested data found in the cache. When the requested data found in the cache, you can say cache hit. And when the requested data is not found in the cache, you can say cache miss. So any cache system, these are two kind of concept: cache hit or cache miss. Cache hit means whatever the data user requesting that's available in the cache and our application responds quickly. So the our objective as possible as cache hit happen so that our applications are as quick as responsive. That's good. So next talks about the cache eviction. What do you mean cache eviction? Cache eviction because the cache is the limited storage, temporary storage, memory. This my database is a larger database, might be clusters of data, right? Cluster of data. So the really all the data are not fit in my cache. So somehow when my cache is full, that means let's say I have decided my cache size is a 10 and 10 record is already is stored in the my cache, and now user request the new data is cache miss no found, that go to the database and call and notice our cache is already full. So where our application going to store new data? So in this scenario, we have to think because our cache storage is limited, we have a limited number of data can store. So some data we have to pull out and some new data may be pulling. So here, this is known as cache eviction. When the cache is full and new data need to be added in the system, then we have to apply some kind of cache eviction algorithms. We're going to talk, but might be, hey, whatever the recently used, we have to remove them. Yeah, whatever the least recently used, we have to remove them. Yeah, whatever the oldest one, remove this. What are the newest one, remove them. So lots of algorithms we're going to talk cache eviction policies through which whenever my cache is full, now I want to put the new data in my cache. there is no space available, then some entry I have to remove from here. Which entry we have to decide on the basis of case to case basis. So those situations known as a cache eviction. That is one thing. And one more concept we have to be understand in the caching system is the cache invalidation. What do you mean that? We have a cache and we are store couple of information, and whenever user request already cache found, I response quickly. What happened, because this is a source of data, this source of data somehow the particular entry store here, this entry somehow modified by here. Something maybe this is the change value in the original source. So if original source change, then if our application is still responding the old value, it is not a good thing, because our applications should respond the correctness value. So in those scenarios, once our source data is somehow updated or modified, so here the old data, outdated data we have in a case, so our responsibility are techniques which we have to update our cache with the latest value, updated value. So when the data in the cache is become outdated or invalidated, it's removed or updated to the original source, so that ensure that the data consistency means ki whatever the actual data, always cache server must have, because the original source data maybe user can go modified, update or some change. So when the particular source of data change, that times we have to go remove the old entry and add the new entry or update the old entry. So this is the kind of a concept, be clear when we talk about the cache. Cache hit, cache miss, cache eviction policies, and cache invalidation. Cache hit means data found in the cache. Cache means data not found in the cache. That means we have to again go to the call original source and get data and update the cache. Once our cache is full, that means we have to remove some entry from my cache. That is the cache eviction. And sometimes our cache entry, cache is not full, cache is not full, but existing entry may be outdated, may be updated by the original source. So that is known as cache invalidation. So lots of cache invalidation algorithm technique available and cache eviction policies lots of available. We're going to talk couple of them, but these are the things we have to aware whenever we are discussing about the cache. So let's talk the types of cache depend upon our nature of application. Generally, we are working maybe client server based application or server side application or maybe distributed. So our caching also not the only one places. You can apply cache on the different layer. Even any request come, go to the load balancer also you can apply caching. Go to the api gateway also you can apply the caching. Go to the my front end application you can also apply caching. Go to the application server also you have to apply caching. Go to the database there also we have to apply caching. So caching means whatever the user requested data, quickly response. Don't calculate, don't get from the original source at the time when user request. So objective of the caching is to response any system, any layer as quick as possible. This is possible. Whatever the data requested, if I have those data, I quickly respond to. I don't have, then I go and find out, hey, which is the data customer requested, then get it. That will take some time. Objective of the caching is improve the response times. And caching can be in the different layer. Whatever the things, maybe front-end application, back-end application, distributed application, client side, API gateway side, database sites, every places you can think where the applications are responding. So those response should be fast, should be quick. This is we can achieve through the caching mechanism. Let's talk about the client side caching. Okay? That means the store data on the client side. Maybe client side means my browser cache, my mobile cache, my mobile app. So whatever the mobile app or browser you are using, this platform also provide the caching mechanism. So we can use them the client side. So in this way, what happened? Let us this is the my browsers. They are sending a request. Hey, this is my application server. They are responding to. Okay, okay. And same data again you are going to ask. Same data again I am going to respond. Why not our browsers or mobile apps? First time they receive data and store somewhere here. And next time, don't go call. Already we have just displayed it. Just display it. So in this way, we have to reduce the number of requests to the original server. And our application is more responsive. Because the same data, maybe you are refreshing the page, are going to the next page and again come in the back page. Okay. So in this way, our application is not going to the call the networks and get the data. Why not our the devices, whatever the client devices we are using, browser, mobile apps, laptop, computer, anything where possible you can store. So typically, the cache library already have it. Like we have lots of we're going to talk like a Redis cache, Memcached cache that integrated the client side application as well as. And these are the generally all the web application, all the mobile apps, all the gaming apps. Generally, many data they are saved temporarily in a cache memory of your devices, of your browser, of your apps, right? And this is a very simple high level flow, right? So this is our application server. Hey, this is my customers or user requesting, hey, I need a particular image. Okay, server responds to the image. Next time again say I need a server. So instead of that, why not in the local cache memory, browser cache memory, store this image? Next times they are getting data from the local cache here itself. So every times for the particular image, particular static file, our system are not going to call the server because our device, whatever the device we are using, whatever the apps we are using, they provide the caching facility. So we can use the client side caching as well as. Okay, so these are the lots of benefits if we are using the client side the your caching, your fast data access, reduce latency, and improve the user experience because user quickly get data. So overall objectives of the caching is the improve the user experience, right? But here also the challenges at the cache invalidation. What happened? The particular image, a particular data are changed on the server side. So this is the things we have to consider when we are going to invalidate because cache means we are storing data temporarily here stored original source somehow something changed then when we are going to update. So this is the challenge whenever you are doing client side validation. This is the way data consistency problem and the security concerns and where such information you are in the stored on the browser side, that's maybe security breach. So every informations you cannot store on the client's device. Okay, so every concept have some advantage, some benefits that also have some challenges. So we as a system design engineer, our responsibility, we have to think on both how to mitigate these challenges and if challenges are more than the less benefit, don't go. If a benefit is comparatively better and we can avoid our challenges, let's go. And for this client side already we have a technology available. You can use Redis, you can use Memcached, you can use cache control header, we can use local store, we can use index DB. So lots of tools in the market will be available. And all the browser, maybe you can say Google browser or Facebook mobile apps, everyone, lots of mobile apps or browser-based applications are using client-side caching. So let's talk another server-side caching. Server-side caching means now our server store data on the server side itself. Maybe different caching layer, different caching proxy, different caching server. So this will reduce the load on the server and improve the response times. What happened? So here, whenever any request come, our application server are store data locally. They are not going to data store from the main source, and they are quickly response from here. So instead of first time they go get data, load here, and every request, they response, they response, they response. So typically these multiple caching layer we can use in our server, maybe a Redis server, Memcached server, or between the application server and database. So here the technology says we have database, we have application server. Don't our application going to call database server. Instead, they are accessing. This is my app server. This is my app server, and generally this is the database. This is my database. Okay, they are originally stored all data. So user request come here, application going to the call database and get and somehow store in the your cache and response here. Next time get cache available response. Get cache available response. So in this way, our caching layer as well as a local cache you can maintain. And generally all the you can say web application, API, microservices, server side caching are everywhere nowadays used to improve the response my API or my request. And these are the basic architectures of the data side. So whenever first time client send request, so here this is our cache server, maybe Redis, maybe lots of cache server available. First time surely cache miss, no data found. Request go to the original server, original database server. Data is get and store in the cache server and response to right. Agar next request again come, already cache hit, data found and response then again cache data found, and so here no communication happen between original server. So any applications, web application or any server side, these techniques are used, sometimes called the local cache or sometimes just use the inbuilt the cache server so that your application is so responsive. And these are the some more benefits if we are using the server side caching. You surely improve the performance, reduce the server load on the server. Now our original servers are receiving less requests, that means they are free to serve more, and in this way can say our application scalability is also can increase. So again challenges, the basic challenge is always cache invalidation, cache data consistency and scalability issue. So we have to ensure that our cache entry must be updated when our original data are changed or modified. The technology we can use, Redis again you can use, Memcached you can use, Nginx you use, Apache HTTP server you can use, lots of caching library nowadays. We have OS cache, Ehcaches, applications, sites, huge list of technology available. And nowadays you can say every application, you go Twitter or you can go Amazon, everyone's using the server side caching. So let's sometime talk about the distributed application. So in distributed applications, also caching play a good role. So here again, store data on the multiple server or node in the distributed system. So here again, our caching provide the mechanism so highly available and scalability and fault tolerance. This is the main key features of the distributed system. Whenever you are designing distributed system, must be highly available, must be scalable, must be fault tolerant. And these are scenario distributed caching help us. And lots of you can say systems we have Apache, Ignite, or you can say Hazelcast. All the use cases you can talk about all the distributed system where distributed caching required, maybe microservices, cloud-based applications, whatever application you are talking, they require the distributed system, right? So here, let's key our simple. Previously, lots of distributed system means lots of our application are distributed system, okay? And every request come on the distributed system. Here, our source of data, the database. Every request come on my original one data archive server. So here instead of one, why not use the distributed cache? Here you can distributed cache. Each application have a separately distributed cache available. They can be called, and we can this data are properly invalidated and sync happen asynchronously. In this way, we can say we can take the benefit of caching in the distributed system as well. So caching is a play role everywhere, you can say client side, server side, distributed application, local cache, distributed cache. So cache to improve application every place, not the specific scenario right now. So again, benefits if we are using caching and distributed caching. In this case, we can achieve high availability, scalability, and fault tolerant issue quickly, and that's way improve our performance. But again, in the distributed systems, we have to get the challenges of the complexity and consistency and conflict resolution problem as well as while implementing distributed cache. So we have to consider those points as well as. And these are technology we can use Hazelcast, Apache Ignite, Redis cluster, and Amazon Elasticsearch as well. Lots of distributed cache available. Amazon DynamoDB, Google Big Table. These are the technologies examples available for the distributed caching as well as. So let's talk about the different kind of caching strategy. That means what the strategy? A strategy means whenever I discuss cache hit, cache miss, cache eviction. That means whenever our cache is full, cache is full, cache is full, and from original data source, I receive the new data where I am going to the put. So putting we have to somehow remove the entry. Which data I'm going to remove, which data I'm going to pull. Okay, so these are the lots of you can say techniques available. So I'm going to talk couple of caching strategy you can say. One is the cache aside, read through, right behind, right around, and refresh ahead. Lots of you can say go to the Google and search out lots of cache eviction policy, cache invalidation policy, cache strategy, or caching policy. You can say this different terminology, but the objective is that how you can maintain your cache because the cache have a limited memory, temporary storage, limited size. So we cannot put every data on the cache. So somehow, sometime after some time, our cache is going to the full, or our cache data is invalidated. The both scenario we have to think how make sure our cache data is correct, up to date, and the number of cache hit is increased. Okay, so objective is that our cache hit as increase our system performance is going to increase. If your cache miss is higher, then we have to think why cache hit is more than cache miss, then we can reduce our application performance. So please be you have to analyze our cache hit and cache miss ratio. We cannot say कि our cache miss is going to so high than cache hit. That is the reduce my system performance. So let's talk couple of them and then we can understand. So as mentioned, cache aside, that means this store data both in the cache as well as underlying storage system. Here objective you can store data in the cache as well as the both, but the provide the fallback mechanism in case our cache is unavailable, cache not available. Then lots of you can use scenario where you can use the whenever you want to our system highly available. That means our system should be always response consistent data. And the scenario where the read is very heavy, you can say we can use the cache aside caching algorithm. Let's understand the details. So this is the steps how our cache. So let's this is our applications user. Hey, I need one data, request the data. Good. Our application server talk to the cache. Hey, if data available in our my cache, hey, data response is done. There is no call to the database. Maybe third case, if data is full and data is not found, then go to the database and then call data. Again, so in this way, different permutation combination. So these are the cache aside say, hey, our application first always reach to the cache server. If data depend upon the cache miss or cache hit. If cache hit, that means we got data, no problem. If cache miss, there is no data. Then we can go in the case of cache miss, you can go to the database, get data, and this data return to the application as well as same time you can update to the database. So for the next times, whenever application going to call from the cache server, they get the data from the cache. So objective is that here our applications are interacting the both interacting to the first cache server. If cache miss, they are okay response to the customer. If cache miss, application going to talk to the database, get data and response back, and same time they update the cache as well. For the next times, our applications get data from the cache. This is the look like the your applications. This is your application and this is your database. Application database talking to each other, but cache is also aside a cache. So first application approach cache data got, it's okay fine. There is application not going to talk to the database, but not available. Request data in cache. Then application going to talk to the our database, response back, and application responsibility is to maintain the cache as well as. This is the meaning of cache aside caching strategy. Okay, so these are the some more benefits of this cache aside caching strategy is the improved performance, high available system, and data consistency. And challenges again, we have to talk invalidation and data consistency problem. We have to ensure that if our data found from cache, the cache data must be correct and up to date. And for these, you can again use the Redis, you can use the Memcached, you can use the caching library icon, and lots of application, LinkedIn, eBay are using this cache aside caching techniques. Let's next about the read through caching. Here, what the data load from the storage into the cache server on demand basis. So here, this provides the one kind of a transparent caching to automate the data loading, and techniques maybe you can Redis or Memcached, and these systems are required automatically load data on the cache. Let's understand details. Here the scenario. So here your applications request, hey, I need a data. Application server talk to the cache server, hey, cache give me data. Get data. If data found, then response no problem. If data not found, go to the database and get return data and return back to them. So here notice, so applications are not directly talk to the database. So here say applications always talk to the cache server. If data found, it's okay fine. If data not found, our cache server go talk to the database, read data, update cache, and cache server say, hey, now we found your data. So our all the read happened through cache. So our applications never directly go talk to the database. So all the read and write happen through my cache. First times go here, cache not available, go to the data write, go back and go back. In this way, you can say our applications getting response through the cache only. So cache hit or cache miss. If any data change, our database technology responsible to update the cache server, right? So you can say our application server always get data from your cache server. In the both case, cache miss or cache hit, our cache server is responsible to returning data. Okay. Somehow, somehow, something. So this way we can our application direct get data from the cache. They read through cache. These are the read through benefits. So again, improve the performance, reduce the latency, and automatically data load in the cache. Again, challenges cache invalidation, cache data consistency. We have to ensure that if my cache is data up to date, any data change from the original we have to update. And Redis server, Memcached, cache library you can use, and lots of example, Facebook, Twitter, all are using the caching layer to read through caching as well as. So one of the another caching technique is write through. So here, write data in the both cache and underlying storage and provide the consistency model, ensure the data is always up to date. And typically Redis and Memcached provide this facility, and they have support a strong data consistency where your high availability plus data consistency is very high required. In those scenario you have to go through these kind of things. So here the details. So what happened whenever one applications call to the application call to the our cache server call to the database, and in this way we can support. That means a write through also happen cache. Our application always data write or read happen through cache. Just right here, and our cache responsibility write data in the database and again read. If any modification happen, application always modified here. So first always data read and write happen from the cache. So our cache is always up to date, and later part cache is going to immediately write the data in the database as well. So our data is going to update it after cache, you can see. So here say write through cache means any data come in the system, first write in the cache and go to the database. So application want to get read, then get it from the cache. So here this cache, so ensure that our data is consistent in the cache always, because the data is written directly into the cache. So lots of techniques and benefits here available. Again, if you want very high kind of a consistency, highly available and improve the performance of system, right through caching help us. And here Redis and Memcached and Ehcache library, and generally all the financial institution e-commerce application where the data consistency is very required, you can think. So where if you want to still improve performance, then go through the write through cachings. One of the technique is the write behind caching as well as. So what they say, write data to the cache and then asynchronous write data in the underlying storage. So write through means our data is written in the cache and same time data written in the your cache. But here say write behind means data written to the cache first, response them, and data later part data are going to the sync in the data. So here we can perform high performance caching layer to reduce the data storage. And again, Redis, Memcached, and lots of system where required very high performance and fault tolerance kind of a scenario where this kind of a caching algorithms we can use, right? So here's the application, write data in the cache and just response quickly. Read data from cache, response quickly. Later, once some kind of data bulk happen, they are going to the sync in a database. Okay, so you can say data is written to cache, written to database from the cache asynchronously, not at the times of a application request going process. So in this way, we can provide the better application response. Again, the scenario where you need the high performance and reduce latency and improve performance, this kind of but here again the challenge is for that data loss in the case of failure, again some cache failure, some unable to write the cache data, so we have some challenges. There's still technology you can use the Redis, Memcached and caching library, and all the real-time platforms are gaming platforms generally use right behind caching strategy. You can say lots of more caching. One is the right around cachings available. In this case, our applications are first going to talk to data in the database. Hey, this is the data. And next, applications are going to read data from the cache. Okay. And if applications are not able to write, then our applications responsibility data from the read, and applications is responsible to update the cache. So here somehow write around a strategy where the applications responsibility to writing the both cache as well as the database. This is somehow the right around, or something you can say a refresh a cache strategy. That means our application always read data from the cache and data asynchronously before expiry, yeah, before a refresh time happen, we have to sync data in the cache. So you can say lots of caching strategy, you can apply any one of them. Okay, and similarly we have a cache eviction policy. These are different strategy the way you can implement our caching. The cache eviction policy are used to decide when which item you want to remove from the cache. Here, till now we discussed how to add data in the cache. Okay, but sometime we have to which I have to remove from the cache. The cache eviction policy say, hey, one cache is full, which data I am going to remove from this cache. So cache action policy are used to decide which items are going to remove from the cache. So it's reach the capacity for the space for the new items are stored in the cache. So couple of policy you can say, and surely we cannot discuss each and everything, but list is so huge. But these are the common cache eviction policy you can say. You have to things like first in first out, first in first out, last recently used or most recently used, least frequently used, random replacement or segmented LRU or time to leave, hybrid, adaptive, optimal. Well, the list is very huge. Just you can also explore, and all this depend upon your application nature, which eviction policy you are going to apply. Be carefully choose them because each have a different approaches the way you are going to remove entry from cache. The objective of this complete the eviction policy means I want place new value in the system in the cache, but there is no space available for cache. The first I have to remove some item from here. We have to remove out one and then we are going to put in new one. So this policy help us to decide I am going to remove the first one or last one, or you can say least recently used, most recently used, least frequently used, lots of techniques which decide which we are going to use them. The one of the simplest is the first in first out. Whatever the this policy simply remove the oldest item from the cache. That means it was the that was added first. Simple. This is a simple to implement. Ensure the oldest item is removed from here. But this is the may not more effective in the case of the oldest items if they are frequently accessed. The particular item you remove, particular you oldest item, this one you are going to remove them, and next again request come for the same, you can go again add. So if data are the first data are frequently used, so these are not become a more effectiveness algorithm. So nature of application, you can decide, hey, I am going to use first in, first out policy or not. But the implementation is very simple. Just put new, put new. You want to remove, just go the oldest one and remove them, right? Similarly, another approach you can think, hey, last in, first out. We are say, hey, whatever the data, I am going to add. Which data is added last? This one last data, remove the last one. So this say policy say remove the most recently added item from the cache. So here say which are the latest set, just remove them. So ensure the most recently data added was the remove first. This can be effective in the case of cache are used temporarily, but also this may not more effective if the last data you added and again you are removed, and again this data going to someone mostly use the last one. So this is also not more cost or more effective eviction policy as well as. So we have to put some intelligence in not the simplest way to implement, but what the problem we are solving. Similarly, you can think least recently used eviction policy. So this policy remove the item that has not been accessed for longer period of time. So here say, hey, this is the cache and lots of data is stored in the cache, lots of data is stored in the cache. This data are mostly used. These are not used, these are not mostly used, this is not used. So notice this data are not recently used. So this policy says remove the item that has not been accessed for the longest period of times. So this is the benefit. Ensure the item is not frequently accessed or removed, which help us to improve the cache hit ratio. So something it may require the additional memory to store the access about the times, but these are the one of the best techniques. Just remove the items or data from the cache which are not used the longest period of times. So this helps us, that means these data are not used are requested by the server, that may not feature also request. Similarly, you can say maybe you can say most recently used algorithm. Here say, hey, this policy remove that was most recently accessed. I mean, that means ki, what are the this ensure that item has been most frequently accessed or keep in the cache. Okay, so this is also kind of good and required some additional memory storage to manage this most recently eviction policy. Some of the technique you can also is the least frequently used. This policy remove the item that has accessed the least number of times. Ensure the items that are not frequently accessed are removed first, which can help to improve the cache hit ratio. So this is the also you can think. This is the techniques that can fit for you. This is work on the number of counts, which items are the least number of times they are accessed. Sometime you can say, hey, why not implement some random policies? Just policy, you can remove any random number of items. Someone can think, say, the simple to implement, but can be effective in the case of a cache, use the temporary cache, but it may not be more effective when we are going to use the frequently accessed data access removed, right? So sometime it's work, but not the most effective. Sometimes someone can apply the time to live eviction policy. The policy remove an item from the cache after a specified period of time. So let's say, hey, I am going to say after 10 minutes, the particular data are going to remove from the cache, or after 10 seconds, or 1 hour, yeah, 1 day. So they are going to be as a configuration basis. Customer or system can configure, hey, we are ensuring that the particular item is removed from the cache after the certain amount of times, and which can help us to prevent the stale data as well as right now. This is the also one of the good technique. Many you can say caching technology ask us the your expiry time. So any data put in the cache when the data is going to remove from the cache. So times is also make a factor when the system or caching server is going to remove entry from the cache. And sometimes you can say hybrid kind of things. You can combine couple of policies. Okay, so policy combine multiple eviction policies such as LRU, LIFO to determine which item removed from the cache. So you can apply the many places. You can say can become more effective than the single eviction policy and take account to the. It's maybe more complex to implement, but it will help many places. Sometimes you can combine the two or three policy and make one hybrid policy, and that's is also make a good performance or more effective policy than the single eviction policy, you can say. So lots of, you can say, policy. I'm not going to talk everything, but let's you can just explore this couple of policy as well, like GDSF policy, LEP policy, HSC, OGD, LRUD, multiple policy, adaptive replacement cache, multi queuing cache. Similarly, you can use the list recently with a combined LRE, LFU and FA, or you can see segmented LRE with the dynamic edging. So lots of techniques you can just explore. If the particular any one of them are not fit for your requirement, you have to explore, because the lots of cache eviction policy we have. So we have a two problem. One is the cache evictions, means ki once cache is full, which data you want to remove from the cache. One thing is cache invalidation, means ki particular data already in the store that are invalidated. There is not make sense to keep the data in a cache. If those data in a cache, that means our applications are responding the old data, not updated data. Sometimes this is known as a data inconsistency problem. Customer face data inconsistency. So for making data consistent, up to date to the original source, we have to ensure that we carefully implement the cache invalidation policies as well as. So kind of a cache invalidation is the process of removing or updating the cache entries that no longer valid or has been updated. It is the essential part of the cache management. It's ensure that cache remain up to date and accurate data. So this is our responsibility. Whenever we are implementing cache, we have to ensure that our applications are getting data from the cache that is up to date, that is the correct, that is the accurate data, not return old data. If your application is responding fast but they're returning the old data, not make sense. Okay, so caching is the surely used for the better performance. But for better performance, improved performance, you cannot say we return the old value, updated value, incorrect data. This is also problem. So we have to maintain the both. This is the way. This is a very important in the caching. Why cache invalidation is very important? Because we have to ensure that prevent the stale data. Cache invalidation prevent stale data from being served to the user, which lead the incorrect informations or either even customers, hey, this is a bug, this is the defect, this is the error. This is not either your application. This is the problem in the caching server, caching in techniques you have been implemented. So unnecessary customer raise the bug, defect for your application. Your application is might be correct, but due to the cache implementation, your application is responding old data. So we have to be carefully invalidate our cache entry. This is also ensure our data consistency. Cache invalidation ensure that certain cache data, if remain old in the system, underlying data sources are changed, which is essential to maintain the data integrity. If your cache Invalidation can improve the performance by removing the unnecessary cache entries, reduces the number of cache. This, if our policy is properly updated, if any data which are not useful, just remove them. Just remove them. Once you remove, your cache is free to hold other data as well as. So in this way, if we are properly place the cache invalidations rule, it's improve the performance of caching itself. Unnecessary stale data you storing, that's maybe not required. Okay, so please be carefully when you are going to invalidate the cache entry. And these are multiple kind of a types of cache invalidation techniques you can think. Maybe time based. Okay, hey, let's decide every 5 minutes data must be invalidated. Invalidated means the entry from the cache I'm going to remove. Add some version based invalidation. Cache entries are invalidated when underlying data source is updated. Hey, from the particular database data update, this cache is also going to update. Or maybe content based invalidation policies, or maybe event based. Let's say particular events, hey, particular data come, yeah, particular new events, yeah, particular specific event source come, hey, clean up the data, invalidate the cache entry. Our content bits decide, hey, based on the contents. So different kind of techniques we have. So we have ensured that our cache entries must be invalidated if the particular underlying source informations are changed. And these are the lots of cache invalidation techniques we can use them. One is the cache tag. Tags are used to identify cache entries and invalidate them, and underlying data source is updated. Maybe you can use some cache metadata concepts. Cache metadata used to store information about the cache entries and their creation and version number of times. Hey, this is the cache entry, this is the time creation, this is the number version. What the source version? If the source version change, hey, just remove the cache entry or make cache invalidated. So lots of you can say cache invalidation algorithm you can apply. Cache invalidation algorithm have a list LRU, LFU to determine which cache entries are invalidated. So multiple algorithms you have where you have an option, we can use them. Even you can use the cache invalidation protocols, such as cache invalidation protocols such as HTTP 1.1 or 2 are used to communicate cache invalidation information between the cache server and policy. Automatic some kind of a protocol supports, our devices supports, browser supports to validate or invalidate our cache entry. So lots of techniques we have you can take, but lots of benefits the caching have with the some challenges to implementation selecting, but good options. All these features about the whatever we discuss, cache hit, cache miss, cache invalidation, cache eviction policy, everything's our responsibility is not to going to implement here. The good option is that this is already inbuilt technology available for the caching. Just we are going to use them and configure them and get all the caching concept itself implemented. So even the caching technology we have available for the open source environment are some commercial as well as. So whatever you want to go for the open source solution, let's go for the Redis, Memcached, Ehcache, Apache, Hazelcast, Apache Goat, OS Quest, Terracotta, J Group, Apache Common Caches, lots of caching technologies already place open source for you. Just you decided, hey, this is my application, this is my database. Between that, I'm going to apply this cache, and cache server is available for you. So good option. Just you aware, just you know, and just this is technology available. Just you can integrate this technology in your application, and your application get the better performance. You can already you're not going to implement all the caching technology, all the caching algorithm, eviction policy, strategy to yourself. These caching concepts are already implemented by this technology. These are the open source available for you. Just you can configure them. Redis and Memcached is highly used nowadays, and all of the other depend upon the different each caching technology have some good documentation. Go through and read, and whatever the use case match with you, you can use this open source caching technology: Redis, Memcached, Ehcache, Apache, Hazelcast, Apache Godi, OS Cache, Terracotta, and the Apache Common Caches. And if you can go to the nowadays cloud, so also all the cloud provider providing the caching technology, caching packages, caching software for you. If you talk about the Amazon have elastic cache, and the cloud front, they have a available. If you are using Amazon cloud, you can just ask, hey, I need the caching for my applications. If you want, if you go to Google have a cloud memory store. They can provide the cloud CDN as well as. Even you talk about the Microsoft have a Azure cache or Azure CDN available. Similarly, talk about the IBM cache have cloud cache and IBM CDN. So you can talk about Oracle Cloud Cache, and even Oracle Cloud CDN. So nowadays, you can say every cloud providers, or you can say commercial caching server available for you. So you can just explore all the caching technology available for you. This caching help us to improve your performance and everything. If you want, just go and read out lots of content available in the open source. Just you read out and study about the lots of caching, whatever the caching we discuss, caching side, lots of technique, read through advanced disadvantage, everything's available. Just you can read out here whatever the available information you have, right? So you can say these are the concept which you can should aware hey, if I want to improve my application performance, at which layer? At the front end layer, at the network layer, at the server layer, at the database layer, at the client, whatever layer, at the application layer, at the different your application component. Each and every component you can think. If your application want to be more responsive, one of the basic technique you can use the caching. This caching technique temporarily store your information and quickly responsive. Okay, so this is the one of the, you can say, outside of the your uh, applications. Just you think I want to improve the performance, just integrate this caching technology in your applications, and you can get better response of your application. Whatever the application business logic you have built, that's good. Maybe you have some effective algorithm, effective database query, everything that's good. You can do, but apart from that, you can get the more responsive of your application with the caching. Caching is the additional layer, more uh, quick response you can base, because here caching layer you are not going to write any code, or just you can going to use this technology which is already available for you, and you can get the better result. That's a good option. We are going to design system, we are develop software, develop algorithm, everything good, that's correct. Our applications are very, our algorithm is very effective, we have written very high quality codes, that's great, they're responding very fine. But on the top of that, you can use the caching, and caching improve the more faster response, quick response to the application, to the user, to the customer. The caching layer is not just for the user perspective. Caching layer can works in the different modules of your system. Maybe between your user to the your application server. Maybe your one application talk to another application at that time. When it be different communication, different component, you think where the request response something happened. Every layer you can say, hey, I am requesting some data and I want to response data. So this layer, you can think here one cache layer. Maybe you are a database request response, microservice to microservice communication response, user to application response, client to server architecture, server to server architecture, distributed architectures, any places you think any kind of request response, one applications are requesting something and one is responding, that is the place where caching can be placed. So caching help us to improve my response time. This is for today. Thank you